Okay, so we're done with point estimate. Okay, so the next important thing in a population estimation is interval estimate. So what is interval estimate? It's a range of values to estimate a population parameter. Okay, so how do we determine the range of values? So you do have your lower limit, so meaning mu is greater than your lower limit but less than your upper limit. Okay, so that's the range of your interval estimate. A range of interval values used to estimate the population parameter. So this is your range of values. Okay, mu, population mu, is greater than the lower limit but less than the upper limit. Okay, so this is your mu. Okay, so mu to this one, you're referring to the maximum error. Okay, allowable error. So how do we determine the maximum allowable error? So that will be mu is greater than the sample mean minus E. When we say E here, you're referring to the margin of error. Okay? Margin of error. But less than sample mean plus E. So E here, you're referring to margin of error. Okay? This one. E is you're referring to the margin of error. Okay, margin of error. So that is your E. Okay. So confidential interval. An interval estimate with a confidence coefficient. Okay. So under the interval estimate, we do have, we call it confidence level. Okay, so what is this confidence level? When we say confidence level, you're referring to how confident you are that the interval estimate contains the true value of the parameter. Okay? Again, another second point on parameter estimation is the interval estimate. So to determine the interval estimate, we need to come up with a range of values. So how do we determine the range of values? So to determine the range of values, that would be the population mu is greater than the lower limit but less than the upper limit. So the mu or the population mu to the lower limit, you are referring to the maximum allowable error. Your maximum allowable error, you're referring to the sample minus the margin of error. So E here, you're referring to the margin of error. Okay? So under the interval estimate, we do have confidence level. So what is this confidence level? When we say confidence level, it can be determined how confident you are that the interval estimate contains a true value of parameter. Okay? How confident you are that the interval estimate contains a true value of the parameter. Okay? So that is confidence level. The table of a confidence level. Okay? So 1 minus alpha over 2, z alpha over 2. So you need this in determining the confidence level. Okay, so you need this table. Okay, so there are two ways to solve it. By memorizing the table or you can do it in a manual manner. Okay? I will explain that as we go along, okay, in the series of example. So going back, so when we say E here, you're referring to a margin of error. Okay? Margin of error. E here, you're referring to a margin of error. So when we say margin of error, you are referring to the maximum difference between the point estimate and the actual value. Okay, when we say margin of error, which is denoted by E, okay, to solve for the margin of error, that will be Z alpha over 2 multiplied by the standard deviation of the population over the square root of n. So this is your margin of error. Okay? So what is margin of error? You're referring to the difference between the point estimate and then the actual value. Okay? The difference between the point estimate and then the actual value. Okay? Okay. So first, under the confidence level, first condition. So the first condition is that, what's the first condition? Finding a confidence interval. So this is the first condition for a mean when the standard deviation or sigma is known. So this is the first condition under the confidence level. Finding a confidence interval for a mean when a sigma or standard deviation of the population is known, meaning it's given. Okay? So first and foremost, we need to come up with 2 points. Sample is a random sample. Next, either n is greater than equal to 30 or the population. Try to remember this, guys. The population is normally distributed if n is less than 30. Okay? So, finding a confidence interval for a mean when a standard deviation of the population or your sigma is known, meaning it's given. Okay? So, what is the concept behind that? A sample is a random sample. Either n is greater than equal to 30. The population is normal distributed if n is less than 30. So, try to remember that one. Okay? So, let's proceed now to example number 1. Okay? Example number 1. I'm gonna read this one. A survey of 30 emergency room patients was 174.3 minutes. Assuming that the population standard deviation is 46.5 minutes, find the best point estimate of the population and construct a confidence interval of the population mean. So, in number 1 problem, what are the given? Okay? So, first, we need to determine the given. So, what are the given? So, you do have N, which is 30 emergency room patients. Okay? And then, what is 74.3? So, that is your sample mean. Why is it 174.3 is your sample mean? Because you are referring to the 30 emergency room patients found that the average waiting time for the treatment was 174.3. If the given sample mean is obviously a sample, so therefore 174.3 is your sample mean. Okay, next, assuming that the population standard deviation is equal to 46.5. So that is your population standard deviation because it's already given in the problem. So find the best point. So find the best point estimate. Find the best point estimate. Remember that the best point estimate is your sample mean. Okay? So therefore, the best point estimate is 174.3. That's it. Okay? Next. Letter B. Construct 99% confidence interval. Okay, so how do we construct a 99% interval? Okay, first we need to apply the alpha. What's alpha? Okay, so in determining the confidence interval, remember that 1 minus alpha is equal to 100%. Okay, 100%. So how do we solve that? Or how do we determine that? So 1 minus alpha, what is the given? Yung 99%. So 1 minus alpha is equal to 99%, or simply as 1 minus alpha is equal to 0.99. Okay, so yun yung hinahanap, yung 99%. So 1 minus alpha equals to 0.99. Okay? So first, solve for alpha. Okay? Try to remember this. 1 minus alpha. So how do we solve for alpha? So alpha is equal to 1 minus 0.99, and that will be using a calculator. Okay? So 1 minus 0.99. So that will be 0.01. Okay? So since we want to construct a 99% confidence level, okay? So to solve for the confidence interval, construct a 99% confidence interval. So mu, so the interval will be mu is greater than the sample mean minus E, and then less than sample mean plus E. So this is your interval. But the problem, we don't have E. So we need to solve for E. So E is your margin of error. So how do we solve that? How do we solve for E? E is equal to Z alpha over 2 multiplied by the standard deviation over the square root of n. Okay? Z alpha over 2 multiplied by the standard deviation over square root of n. So the standard deviation is already given, which is 46.5, and n is given, which is 30. So what is missing is this one. Okay? This one. Z alpha over 2. Remember that 1 minus alpha